So first thing, what is viscosity? Viscosity is similar to friction. Like, friction is for solids, viscosity is for fluids and gases. So opposition to the relative motion between fluid layers in contact. This property is called viscosity and the force is called viscous force. So if you see, the definition is quite similar to friction. Friction is what? It is an opposition to relative motion between two solid surfaces in contact. Here it is two fluid layers in contact. That's the only difference. So you can simply say friction in solids, friction in fluids is called viscosity. Now, this is a theoretical question. If you increase temperature, for liquids, the viscosity decreases. For gases, it increases. So this they'll ask you in a BitSat and JEE mains level question. With increase in temperature, what happens to viscosity of gases and viscosity of liquids? Now, what is the reason? In liquids, the bond distance between the molecules increases. So whenever you're heating, right, the liquid expands and the distance between the bonds increase. So this leads to lesser interaction. So there is less viscosity. Whereas in gases, molecules are already very far. But when you increase the temperature, molecules will start, colliding more and more. The molecular collisions increase. Because of molecular collisions, right, there's more interaction. So this leads to increase in viscosity. So the reason is different for both of them. So for liquids, the bond distances will increase, interaction decreases, viscosity decreases. For gases, molecular collisions increase, which increases interaction, so viscosity increases. So remember this. So for liquids and gases, viscosity varies. It's not the same thing with temperature. Any doubts on this page?
So just one general एक चीज पूछना था. So
Yeah.
This is continuation of fluid mechanics only.
You can say however you want. Fluid mechanics, properties of matter. In HCV, there's a different chapter.
Okay.
Clear? Next thing, Newton's law of viscosity. So what this thing says, consider a plank right moving on a fluid layer with speed v. Now, if the plank is going forward, the friction will be backward. So here we can write this as viscous force. So I'll use the symbol F only. Now, this formula is completely derived experimentally. If you ask me, this is the primary formula in the chapter. So it is given by F is equal to minus eta A dV by dz. Eta is coefficient of viscosity. Now here, one important thing. The units of eta are poise, but this is a CGS unit. 10 poise is 1 SI unit. So in the exam, right, if they give you eta is 30 poise, you should use eta 3 in the calculations. So be careful with that. Don't use 30 directly. That will give you a wrong answer. And options will be like this only: 1, 10, 2, 20. So by mistake, if you put eta is equal to 30 and so on, you'll get a big number. So this is one thing you have to be careful. Poise is a CGS unit, 10 poise is 1 SI unit. So eta is similar to mu. Mu is coefficient of friction, eta is coefficient of viscosity. A is the area, dV by dz is the velocity gradient. I'll explain that in more detail. So A is the area in contact with the fluid. dV by dz is called velocity gradient. If you remember, anything that changes with position is called gradient. Just like dt by dx was temperature gradient and thermodynamic heat transfer. Right? So this is the formula which we're going to use. Any doubts on this page?
No, sir.
And then the negative sign indicates opposition to the relative motion. Fine. That is, again, negative sign does not oppose the motion. See, friction does not oppose motion. It opposes relative motion. So what is this delta V by delta Z? For example, if you take a layer here on the right hand side, right, at a distance of Z1 with velocity V1. If you take a layer here with velocity V2 at a height of Z2, then delta V by delta Z is given by relative velocity between two layers by distance between two layers. So it is V1 minus V2 by Z1 minus Z2. So the delta V by delta Z is that. Now dV by dZ can be assumed to be a constant for thin layers. Normally dV by dZ is not constant, but when the layers are very thin, you can assume it to be a constant. And one more thing here, F is equal to eta A dV by dZ, F by A is not pressure. Remember pressure ka definition? What is pressure ka definition? Force perpendicular to the area. What is this force? This is parallel, isn't it? This force is tangential to the area. So this is not pressure. There is a different name for it called shearing stress. What is shearing stress? We will deal with that later on. That comes in elasticity. So simply it's tangential force per area. So whereas pressure is F perpendicular by area. So this F by A is not pressure. So be careful with that. Okay. Then now
Sir,
this
it's
is one.
like,
Bolo na.
sir, for thin layers, it can be assumed to be constant क्योंकि like we can ignore a small change in
Small changes. It is like dV and dZ.
small changes.
Yeah.
Okay,
Yes.
okay.
Next thing, we assume the fluid layers in contact with the solid have the same velocity as the solid surface. What do you mean by that? For example, if a plank is going with speed v, the liquid layer touching the plank will also have the same speed v. For example, if you take a river, the ground is at rest, so the liquid layer touching the ground will have zero speed. As you go up, the speed increases. So if you see the velocity profile of a river, this is how it looks. So when a river is flowing, the upper layers will travel faster, the lower layers are traveling slower. So the closer you are to the solid surface, you will get the velocity of the solid surface. So this thing is mostly valid, for most of the surfaces. So the liquid layer, which is touching the solid surface, will have the same speed as a solid surface. So if you see, right, if the river is moving very fast, if you observe the fish, you'll observe the fish at the bottom of the river, right? They're not getting dragged away. They're happily swimming there. The reason being, even though the river surface is going very fast, the bottom layers are almost at zero speed. So whenever a fish wants to go opposite to the river, it will swim below the river at the ground level. Whenever it wants to go in the direction of the river, it will come to the surface and swim. So if you have a submarine, right, going in a big flow, so ship and a submarine, ship is on the surface, submarine is at the bottom. So when they're going opposite to the river flow, the submarine will go faster. The ship has to go opposite to the river flow, whereas the submarine at the bottom is almost at zero speed. Same thing if you take the velocity profile in a pipe. Now in a pipe, where is the solid? Circumference. So the circumference means if speed is zero, center पे speed is maximum. So inside a pipe, assuming neglecting gravity, the water will flow like this. The center of the liquid is going faster and the edges are going slower. The velocity profile will be parabolic. We are going to prove this later on. This will be a parabola. So basically, end of the day, the velocity, right, of the solid surface, whichever you're touching, the velocity of the layer will have the same speed as that solid surface. Now, if you think about this, it is that yeah. You have a cardboard box, small hole. So the smoke machine normally which they use in Vilkas and everything. Now the box is full. So when you hit this, the smoke comes. In this moment. Can you see that ring? You can see this thing, normally, in Tom and Jerry, right? Sometimes the Tom takes a cigarette and smokes, it releases rings. Ever remember that episode? It gets round rings. And even some smokers also do that. They release rings when they smoke. The concept, right, of getting this ring is this only. What happens? See, when you hit this, so when you're hitting that box, ideally speaking, what should come? You should get a cylinder of smoke. But remember, just now I said the outer edges will travel slower, the inner edges will travel faster. So what happened? The air in the middle traveled faster, so it went away. So what is left? The circumference.
Okay, mate.
Does it make sense? So the whole concept of this thing is that only the edges are traveling slower, the center is traveling faster. The center went away. What you got is a ring. So this thing is called a vortex cannon, basically. So this is the principle behind that. This is a simple thing. You can try it out with an Amazon box. So you can use this as a weapon, to disperse crowds. You can shoot people with compressed air. So that was one. Yeah. Let's see a question. That's it. That is the main concept there. F is eta A dv by dz. So this is the top view. So we have surface 1, which is going with speed 2v. We have surface 2, which is going with speed v backward. The distance between them is 4d. We have a plank in the middle, right? Distance is d from the top and 3d from the bottom. Assume dv by dz is constant, linear function. So surface 1 moves with speed 2v. Surface, and surface 2 moves with speed v as shown. So you have a plank of area A pulled with a constant speed v. So, the diagram looks like this thing, the side view. So you have two walls like this, and the plank is in the middle. Can you visualize? The room you're sitting, right? The left wall, right wall, you're in the middle, you're a plank. So you're going parallel to the walls. Able to visualize? So the question is, you're applying a force F and the plank is going with constant velocity. So that's the first question. Find F to maintain the speed. How much force should I apply on the plank so that it maintains with the speed? Neglect gravity. The second question, where should I keep the plank so that I need not apply any force? The plank is going with speed v, where should I keep it so that I need not apply force? Two different questions. First question, how much should I apply at this position to maintain constant speed? Second question, where should I keep the plank so that I need not apply any force? Read the question, have a look at it. You're confused, please ask me, I'll explain the question again. Others, keep your cams on. One is missing, right?
So this second part of my F0, so that it goes with constant speed, right?
If it is going with constant speed v and I don't want to apply force, where should I keep it?
Okay, sir.
Any answer? Omega is not there, right? Use missing. Okay. How to do this thing? Free body diagram. See the free body diagram. How to get the forces? No, you're moving with a constant speed, no? You're going with a constant speed. Don't want to keep it at rest. Look at this thing here. How do you find the relative speed? This guy is going with 2v. This guy is going with v. What will be the direction of friction? Think of it like this. You have 3 blocks like this. This is going with 2v. This is going with v, and this is going with v. What will be the direction of friction? On this f backward, on this f forward, right? On this f2 backward, on this f2 forward, isn't it? So you get the direction of friction the same way you do it for this thing also. Since the upper surface is going faster and this is going slower, f1 will be forward. The lower surface is going back, this guy is going front, so f2 will be backward. This is the direction of friction. Then how do you calculate f1? F1 will be eta a 2v1 by d, eta area relative velocity 2v minus v by distance between them. What is f2? Eta area relative velocity v minus of minus v, because both are going opposite, by 3d. I got f1 and f2. Since it is going with constant speed, acceleration is 0. F plus f1 is f2, solved. I got a minus sign. What does that imply? Force is not forward, it is backward. Let's check your numbers once.
सर F1 और F2 लिखते वक्त माइनस साइन नहीं आएगा?
नहीं, again, what does the minus sign indicate? Opposition to relative motion, ना?
Yes, ले लिया वो तो.
तो इसीलिए F1 का direction ले लिया ना?
Yes,
Remember, in physics, we'll never use the signs. The minus sign indicates opposition that you're drawing in the diagram.
okay, sir.
Any doubts on this thing? Please ask me. Any step you didn't get? Clear? What about the second part of the question? Question is still not over. Where should I keep the plank so that I need not apply force if I want to maintain the speed?
So F1 should be equal to F2, right?
Yeah. So where is that position?
So 4 by 3D.
Yeah, let's see. So let it be placed at a distance x from the top and 4d minus x from the bottom. So F1 should be equal to F2. What is F1? Eta a relative velocity by x, eta a relative velocity by 4d minus x. Equate them. You end up with 4d by 3 from the top, 8d by 3 from bottom. So it depends on which x you're taking. Check it out. Basically, if both the forces become equal, you need not apply any force. Clear? Next one. We have a long incline with a plank on top of it. There's a thin layer of fluid. So this is a Z thickness. it's a very thin layer. Viscosity is eta, gravity is there, angle theta. To find, initially it is at rest. So the plank is sliding on the incline. Find the velocity of the plank as function of time t. So you have a long incline with a thin layer of fluid. It's like honey or something. You kept a plank on it, so it is sliding on that incline. It is a thin layer, viscosity eta, thickness z. Mass of the plank is m. Find the velocity of the plank at time t.
The fluid kept at rest.
Fluid is at rest. So
Or
just a thin layer. You're just sliding on it. Any doubts in the question? Please ask me. How do we start? After time t, let the velocity be v. So how many forces are acting on the plank along the incline?
2.
2, no? Mg sin theta minus viscous force is ma. Mg sin theta minus friction is equal to ma. What is viscous force? Eta a v by z. So you get mg sin theta minus eta a vz is equal to ma. A is dv by dt. Then you have to integrate. Integrate. And that's the integration formula. Integral dx by x plus b is 1 by ln ax plus b. Get it? These are the things which you'll get in paragraphs. Viscosity may actually write either the questions are easy or the questions are tough. Like integration based and also. These are some of the questions I made up. Get them. So once you got till here, actually the physics part is over. Now it's all calculations only.
सर v by z इसलिए लिया क्योंकि layer
Thin
thin
layer. Yeah. See, basically here now, when you say v by z, you are taking between which velocities? This is the ground, na? This guy v is 0, this guy is v, right? This distance is z. So you're taking distance between the plank and the incline. Got it?
got it.
So when you say dv by dz, you're taking the relative velocity between the plank and the floor and the distance between the plank and the floor. Floor is not moving anywhere. So you got v minus 0 by z. Check your integration. Everyone should be comfortable with this level of integration. So this is V Planck minus V incline by Z, which is eta A V by Z. Check out the integration. Any step you didn't get, please ask me. So we get in this form dV by A plus Bx. That's constant. Eta A by Z is constant. Then ln A plus Bz and substitute 0 to V, ln A minus ln B, ln A by B, and you end up with this. So if you look at the velocity here, it is changing exponentially. When time tends to infinity, velocity becomes constant. So the Planck's speed is always increasing, but it is getting closer to a certain fixed value. Clear? Any doubts on the steps? Please ask me. And they'll ask you like this thing, plot VT graph. Can roughly tell me how will VT graph look like? Plot VT graph, AT graph, XT graph. If I have to plot XT graph, VT graph, AT graph.
It will be an increasing function.
Plot and I'll give you a minute. Roughly plotted, I'll give you a minute. Meaning they'll give you 4 options to eliminate, but you roughly plotted how it looks. I'll show you. Plot XT, VT, AT graph. And AV graph.
VT,
AT, XT, AV. Om is very happy today. It's a good thing. People should be happy. See, these are the 3 graphs. The blue one is the VT graph. Initially velocity is 0. As it increases, so this is your velocity time graph. So the value becomes, something called terminal velocity. When t tends to infinity, the velocity becomes mg sine theta z by eta a. So this is called terminal velocity. So terminal velocity is the final speed basically. A constant speed at infinity. So the velocity will tend towards that velocity, but it will never reach there. It gets closer and closer. What is AT graph? If you look at AT graph, it is decreasing function. As time tends to infinity, your acceleration becomes 0. Initially, it is g sine theta. When the velocity is 0, the acceleration is g sine theta. What about XT graph? XT graph is an increasing function. And when velocity becomes constant, XT graph becomes a straight line. Remember, an XT graph slope is velocity. So when velocity becomes constant at infinity, XT graph becomes a straight line at infinity. And this is the AV graph. AV graph is simply a straight line. You can look here, y is equal to mx plus c. So AV graph is a straight line. So they can ask you like this also. So why this is important, right? They'll ask you like this: find the time taken when the speed becomes half of v terminal. Then you should know how to integrate this stuff. Check out the graphs. Any particular thing you didn't get, please ask me. So they can play with graphs. They can ask you velocity as function of time t. They can ask you terminal velocity. So that much things are there. Any doubts on this?
Sir, I did not get the XT graph.
XT graph, see now. When the velocity, what is happening to x? It is increasing, right? Position, na? X is position. Position is increasing, na?
Yes, sir.
Now tell me one thing. Finally, when velocity becomes constant, position is still increasing, right? But then that means what? The velocity has become constant. The slope should become constant.
Yes, straight line.
So this slope, na, tan theta will be V terminal. So when it will become straight line at infinity, na?
Yes, sir. Got it.
So till then it's a curve. Infinity may it gets closer to this green line.
Got it, sir.
So this green line is there. This is a straight line. So this tan theta would be V terminal. So in XT graph, the final slope is V terminal. Clear?
Sir, XT graph कैसे आया?
हाँ रे.
Sir, how did we get XT graph?
See now, velocity is increasing function, right? So slope should be always increasing. So slope is always increasing, no? And finally the slope is becoming constant, isn't it?
अच्छा, okay.
So if you know VT graph, from there you can derivation is important. Advanced may they'll ask you in a paragraph, right? So you should remember the process. But mains and bit set level, the formula is sufficient. And this question, so they never asked in advance before also, R by root 3. This is something new. At which point on the pipe, the water flow is maximum. Plot volume flow per second graph, anything. They could ask anything from here. Check it out. Any step you didn't get, please ask me. Clear? Any doubts? You don't have any questions in HCV also. I'm not sure how is your booklet. We'll be sending a small sheet also end of the class. Viscosity. So make sure to practice. Next Wednesday, we'll have a 10 questions test on viscosity. So other than the Sunday test, weekdays also, I'm going to give small test, mini test, 10 questions. Whose results also will be posted in the group.
Sorry?
No, I'm just saying whose results also will be posted in the group. If you're not writing the test, we will put in bold, absent, bunk, exam is bunked, something of that sort. Clear? Any doubts on this? It's important derivation. See, everyone should, after the class gets over tomorrow, take a rough sheet, derive this thing on your own. Every question we did, you should do it on your own again. Do that. Right now, you all understood. But if this comes on Sunday exam, you won't be able to do. So this is the volume flow per second. This is the final result. Now here, see. This volume per second pressure, I can just, rearrange the equation like this. This thing we have done in heat transfer, remember? Thermal resistance. So we can do something similar here also. The volume per second is like current, pressure is like voltage. This quantity is like resistance to liquid flow. So this thing looks like Ohm's law. So the resistance is given by 8 eta L by pi r power 4. So this thing is resistance to the liquid flow. High bigger the resistance, more difficult for the liquid to flow. So whatever you did in heat transfer, everything is valid. Series, parallel, Wheatstone bridge. Like this is the second time it came. It comes again 2 more times, this concept. So you can note down this formula, right? This formula and this thing, note it down. So we're going to do problems based on that. Okay. So series. When do you say two pipes are in series? If they have the same volume per second, we call they are in series. How do you solve? Resistance 8 eta L1 by pi R1 power 4, 8 eta L2 pi R power 4. R equivalent is R1 plus R2. You can just add them up like series resistors and everything. What is parallel? Remember, resistance parallel meaning same voltage difference. Here, same pressure difference. So all this stuff is exactly like heat transfer. Only difference there we talked about heat flow. Here it is volume flow. Their temperature difference, their pressure difference. Their thermal resistance, here it's liquid flow resistance. Parallel, same pressure difference. 1 by R equivalent is 1 by R1 plus 1 by R2.
Sir, can you please show the series?
Yeah.
Thank you, sir.
Clear?
So 1 minute.
Yeah.
Done, sir.
Let's say a question. We have two pipes of radius 2r and r, length 12 and L. Pressure is 2p naught and pressure is p naught. Find the liquid flowing per second and find the pressure at the interface. You know how we did this question in heat transfer? We have two cylinders. Thermal conductivity 2K, K. Length L, 2L. Temperature is 2T naught, temperature is T naught. Find the heat flow and find the temperature at the interface. Exact same question. We just changed everything into pressure and volume flow.
So like small doubt hai. So in the center we'll take radius as R, right? Or
The interface, it doesn't
Yeah.
matter. It depends on which one you're taking, the left pipe or the right pipe.
left, then
So what do you want to find? For the pressure?
yeah, the B part.
See, first, what is the volume flow? Find resistance R1, R2. R equivalent is R1 plus R2. The volume flow per second is pressure into R equivalent. Na? Next thing, let the pressure be Px here. So can I write like this? This pressure difference by this resistance should be equal to this pressure difference by this resistance. Because pressure difference across the pipe by resistance will give you volume flow, isn't it? So I get Px from there, na?
Yes, I understand.
Check it out, everyone. Others, keep your cams on. Any doubts on this? Next one. I have a Y-shaped pipe. The radius is length L, R, 2R, this thing, eta. Pressure is 3P0, 2P0, and P0. Remember this question, 3 rods. 3T0, 2T0, T0. Find the temperature at the interface. Find the pressure at D and the volume flow in each cross section, each section. Hope you can see the resemblance. Clear? How to do?
So A to D is equal to D to B plus D to C.
Perfect. So volume flow from here to here should be equal to this and this. So let the pressure be PD at the center. So 3P0 minus PD by resistance, PD minus 2P0 by resistance, resistance. I took the resistance R as this thing. 8 eta L by pi r power 4 is r. So this will be 2r and this will be r by 8. Check the calculations. So once you got PD, put it back in each one. You'll get volume flow in each section. If you remember, we have done something similar in thermal resistance also. Check out the steps. Pesca website is also similar, right?
Sir, it's horrible. It's horrible.
Okay.
Sir, बहुत crash होता है, बहुत crash होता है.
This thing na, actually Bansal classes are there na. The same guy who did for Bansal classes is selling the platform. I took it from the same guy. So this is tried and tested.
हमारा टेस्ट से क्रैश होता है 5 मिनट का टेस्ट दिया और बंद हो गया और फिर इनकम्प्लीट टेस्ट लिख के आ रहा था
सर लिटरली मेजर टेस्ट के टाइम पे ऐसा हुआ
हाँ ठीक है ना एटलीस्ट वी तो हैव ओनली लाइक व्हाट 40 45 किड्स नॉट इट वोंट क्रैश
सर उन लोग को इतना भी अक्ल नहीं है 2000 kids are giving the exam at the same time they don't have that much sense to improve their servers वो भी TWT के टाइम भी हो
देखो ऑलरेडी हो गया some people wrote
oh
they wrote only for 11 minutes फुल आ गया स्कोर
congrats
याद थे थोड़े बहुत
so there's someone Sanvi also wrote for 11 तो
So वो तो TWT crash हुआ but still didn't fix it for major tests.
Come again?
So the pace site it crashed for the TWT also, but then they didn't fix it for the major test.
पता नहीं. And these questions run see after writing the paper, right? When you go through the questions, you can bookmark them. So basically, after 2-3 months now, you'll get a collection of all the wrong questions you did. So this will be good for revision. Check it out. Huh? Just go through the browser, play a little there and here. You will understand. You can save the wrong questions. You can bookmark them. There are different options. It will show you, you know, even you spent how much time for each question.
Sir, there was an option to send a verification email, but कोई ऐसा email आ ही नहीं रहा है.
Yeah, not required. मैंने send कर लिया. Admin added it.
Oh, okay.
You don't require.
सर ग्रुप पे मत डालो ना मतलब
अरे
बाद में क्या
चल we won't put in the group. We'll send it personally to the parents. Whichever you prefer, like. Actually, this thing, there is also a feature like, you know, after writing 4-5 tests, each student ka result, all the tests he wrote also will come. So that also I was planning to send every month, whatever tests you wrote, I'll be posting that individually to your parents.
ये वाला टेस्ट सैंपल टेस्ट था ना
ये sample है this thing. This I won't consider, don't worry. Chalo, which one, Rich? Remember this thing? If this ratio by this ratio and this becomes equal to this ratio, you can remove anything in the middle. How did we get that? When two resistors are in series, right? The current will be same. So we get V1 is IR1, V2 is IR2. So V1 by V2 is R1 by R2. That means when this ratio is maintained, potential at A and potential at B becomes equal. So if you connect anything between A and B, potential difference is 0. So it is useless. So this is the actual thing there. If R1 by R3 and R2 by R4 ratio is maintained, this ratio by this ratio, you can remove R5 in the middle. This is valid even for water pipes also. So if a water is flowing through a pipe, R1 and R3 and R2 by R4 is valid. Water does not flow in the middle pipe. So when you're designing, you know, a water system for a city, and if you don't design properly, any house which gets a connection from here now won't get any water. because there's no pressure difference. Put it down. So this is the Wheatstone bridge and water pipes. Remember this concept. Again, this will come in capacitors and current electricity. 2 more chapters it will repeat. So total this concept comes in 4 chapters. Heat transfer, Poiseuille's equations, viscosity, and capacitors and current. Any doubts on this? Spherical body. You can't use this for anything else. Is proportional to the radius and relative velocity with respect to fluid. This is important. Generally, people at 6 pi r eta v. V is not velocity of the body. It depends on the relative velocity. For example, let's say you are walking in a railway station platform. Okay. If you're walking slower than the crowd, what will the crowd do? They'll push you, right, with you. That means the resistive force is actually in the forward direction. If you try to walk faster than the crowd, then what will happen? They'll oppose you. The guy in the front will push you back. If you walk with the crowd, there's no force only, no? Are you able to get it? So if the liquid and the ball are going with same velocity, there is no viscous force. So that is one important thing. So the Poiseuille's equation 6 pi r eta v, v is the way relative. Negative indicates opposition to relative velocity. Put it on. So this is the Stokes law. So this is the third formula which you should remember.
Sir, F is frictional and the viscous.
Viscous force.
So then what's the difference between the formula which we discussed earlier and this formula?
Actually, now with that formula, when you apply it on a spherical surface, you integrate, you'll get this thing. We don't have the derivation.
Oh.
So actually, that formula is the primary one for everyone. Right? Then let's do a question. You have a ball of mass, density rho b, radius r, initially at rest. Liquid density is rho l, viscosity eta, gravity is there. It is dropped into a liquid. Density of the ball is greater than rho l. Find the velocity as function of time t. You took a ball, you dropped inside a liquid. Density of the liquid is rho l. Radius of the ball is r. Density of the ball is r rho b, initially at rest. So initially, ball ka velocity is 0. So mg will act downward. How many forces are there on the ball? 3. Buoyancy force, viscous force, and mg. Get it? Viscous force is 6 pi r eta v. Buoyancy force is rho liquid 4 by 3. You know this stuff. You have to integrate. Try. I'll give you 2-3 minutes.
So
Yeah.
once out, so in this formula, if we take the direction of relative velocity like correct, then we don't need that minus, right?
Yeah. For example, see, let's say liquid is flowing with 3v. The ball is going with V. How should the friction be?
Ahead on the ball.
Bas ho gaya. So just take the magnitude. This will be 6 pi r eta 2V.
Okay, understood.
Or see, if you take negative also, the sign will automatically take care of it. Minus 6 pi r eta V minus 3V. Na? Minus or minus becomes plus. So
Okay,
it will come forward that way. You get big integration. Check the equations. So weight minus buoyancy force minus viscous force is mass into acceleration. So what I did, I just rearranged the terms. I wrote this entire thing as A and this entire thing as B. It's constant only. Then it becomes simply dV by dt is A minus BV. You know how to integrate this thing. This Lotka integration, learn it by now. This will keep coming like anything, like in entire electromagnetism, this thing keeps popping up. Did they start calculus? Max mein? Limits?
Yes, sir.
Yes, sir.
Started,
Limits
no?
हो गया.
Limits of
Then they'll start differentiation next and integration. They should reach 2-3 months, it should be over. Then you will think all these are jokes. Put it down. So we got velocity A by B is 1 minus e power minus bt. So this is the velocity as function of time t. So if you see all the results in this chapter, if you say most of them are exponential. Check it out. Any doubts on this thing, please ask me. Take a break. Come back to 7:30. Any doubts on this thing? Anything so far we have done? Any doubts on this thing? Ask me.
No, sir.
Chalo, go take a break then. Come back by 7:30.
Sir, I have a doubt.
Bolo na.
Yeah, sir, in that disk question, disk and omega naught वाला question. सर उसमें फर्स्ट स्टेप नहीं समझा मेरे को. dv by dz को x omega by z क्यों लिखा?
What is dv by dz? Velocity between the two layers by distance between the two layers.
Yes, sir.
So here, what are the two layers? ये एक layer था और ground में एक layer था. You're talking about between these two layers, ना?
Yeah. Okay.
So velocity is x omega. Velocity is 0.
Yeah, got it.
Remember what is dz? Velocity layer. Got it?
Yes, sir. Understood.
Yeah. Suppose अगर सोचो ground भी rotate हो रहा है. Let's say ground is rotating with omega 1 and this is rotating with omega 2. Then the relative velocity will be omega x omega 2 minus x omega 1.
Yes, sir. Got it.
That way. So directly you'll get V terminal from this. So this formula everyone has to remember. Others, keep your cams on. So 2 by 9 r square g eta rho b minus rho L. And if you observe here, V terminal is proportional to r square. That means if you take a ball of radius r and 2r, the 2r will go 4 times faster than r at infinity. And this is a graph, VT graph and AT graph. Yeah. This formula you have to remember. So this is the fourth formula. Clear?
सर एयर का वी टर्मिनल का कुछ मेथड अलग रहेगा?
Come again.
सर द वी टर्मिनल इन एयर if you want to find.
For V terminal आपको सिर्फ चाहिए ना, you can put A0 here ना, directly you'll get it from this one step. Integration का जरूरत नहीं.
तो सर I'm saying that V terminal अगर एयर में निकालना होगा तो कुछ अलग मेथड रहेगा.
The method is same ना, but this eta will be for air and this will be air.
अच्छा. Okay.
Instead of rho liquid, you'll put everywhere for air. Meaning this is the reason why you don't die when it rains. Just think about it. When it rains, the height of the water drops, right? It's almost 2 kilometers, the clouds. So when they're falling from that height now, they reach a speed of around 200 meters per second. If the raindrops hit you with that speed, you'll get holes on the head. But when they actually hit you, right, the speed is almost like 15-20 meters per second because of this terminal velocity. So if you throw humans into the air now, we reach terminal velocity of around 180 to 200 kilometers per hour. So if you go for skydiving, so I went for skydiving some 3 years back. So first they'll take you on an aeroplane 3 kilometers height. Then there is a guy who will tie you like a baby in front of you and he jumps. They won't let you jump on your own. So 30 seconds free fall, huh? Meaning for 30 seconds, no parachute, nothing, you're just falling from a height of 3 kilometers. So you guys should definitely try once in life. It is fun. You will remember all.
Parachute खुला नहीं तो सर क्या करें?
Now see na, the guy who was jumping with you, he's also risking his life. Na? They'll have 2 parachutes normally. So then for 30 seconds it was free fall. When I was falling so fast, I must have hit around 200 kilometers per hour. Cold wind is hitting your face, and then they open the parachute. So then you decelerate and all. So yeah, it is fun. So look at this thing. How slow it comes. So basically, the ball has reached terminal velocity, coming down with a constant speed.
So is that slow motion or actual velocity?
That is actual velocity. It's a live rate, meaning it's not a graphics or something.
Okay.
Clear? Now, there's something here. After reaching V terminal here, now see there are 3 forces acting on the ball. So this is some theoretical discussion, okay? So let's say after reaching terminal velocity, what is happening? You're losing potential energy per second. Let's say your terminal velocity is 1 meter per second. Means every second you're losing potential energy of mgh. Agreed? What is happening to this energy? 1. What will the friction do? It produces heat. So heat produced per second is nothing but power due to viscous force. What is power ka formula? Force into velocity. What is force? 6 pi r eta v. So this is 6 pi r eta v square. So heat produced per second is proportional to r power 5. This is important. That means if I take a ball of radius r and a ball of radius 2r, the 2r will produce 32 times more heat. So this they'll ask in integers, huh? A ball of radius r and 2r are dipped into liquid. The heat produced is proportional to r to the power of n. Find n. N is 5. Velocity is proportional to r to the power of n. N is 2. Clear? Now look at it. Another thing is this. Viscous force is creating heat. Fine. Mg is giving you the energy. Fine. What is buoyancy force doing? If you look at power due to buoyancy force, it is minus Fb into V. Where is this energy going? Viscous force is producing heat. See, you're losing gravitational potential energy that is being taken by viscous force and buoyancy force. Viscous force is producing heat. What is buoyancy force doing?
Sir, waves.
Are
Sir, displacement of waves.
displacement of the waves. Which